You're waiting on a train platform. You glance up to check the time. For a split second, the red hand on the clock just hangs there. It stays perfectly still for slightly longer than a normal second, defying the mechanical rhythm of the machine. This temporal illusion is called chronostasis. Whenever you fixate on a new target, your brain overestimates the duration of that first impression. In these moments, your biology is already manipulating your timeline. We tend to think of human vision as a live broadcast, two organic video cameras continuously streaming an uninterrupted feed of the world into our minds. In reality, your eyes move in violent, rapid jumps from one focal point to another. These sudden shifts are called saccades, and they happen constantly as you scan your environment. Because these movements are optimized for sheer speed, the raw visual data hitting your retinas is incredibly blurry. If your visual cortex actually processed that movement, your daily life would look like a nauseating, high-speed camera whip pan. To save you from constant motion sickness, your biology employs a mechanism called saccadic masking. The brain physically cuts off the processing of retinal images during the exact duration of the eye movement. When you add up all those micro-moments of suppressed vision, you are functionally blind for about 40 minutes every single day. Your continuous experience of the present is a manufactured illusion. If the connection between your eyes and your brain is being severed that often, you might wonder why you don't experience a flickering strobe effect of black flashes every time you look around a room. This diagram illustrates how your brain handles that empty space. It uses neural antedating, a post-production trick, to patch timeline holes. Once eyes land on a target, the visual cortex stretches that crisp image backward, overwriting the missing period of the saccade. This creates a strange chronological paradox. You recall seeing the clock on the wall before your eyes actually finished moving to look at it. This occurs because the flow of time is not a physical law you passively observe. It is actively generated by specific neural structures deep within the cerebral cortex, like the precuneus, which weaves sensory inputs and memories into a unified timeline. Your experience of now is a delayed, post-produced broadcast, scrubbed of glitches and neatly edited by your neurology to maintain a coherent, unbroken narrative. We can see what happens when we push this temporal rendering engine to its limits. Think about driving on an empty highway for hours. You might pull into your driveway and realize you have absolutely no memory of the last 50 miles. You navigated curves, adjusted your speed, and stayed in your lane, but the subjective experience of that time is completely gone. This is highway hypnosis. It triggers when your visual cortex receives a continuous diet of monotonous sensory input, like a ceaseless parade of dashed white lines. Without new, novel events to act as temporal anchors, your hippocampus stops timestamping the incoming data. The brain determines that the repetitive scenery isn't worth storing, so it simply stops rendering the subjective passage of time. Your perception of duration relies strictly on the creation of new memories. Without cognitive novelty, the footage of your life is discarded on the cutting room floor. For most of human history, this biological editing room worked perfectly. But today, our ancient neurological hardware is colliding with the engineered velocity of the digital era. Infinite scrolling interfaces, unpredictable notifications, and algorithmic feeds force our visual and cognitive systems into a relentless state of rapid attention shifts. We are making thousands of microsaccades across screens every hour. Psychologists call the resulting state time famine. It's the modern paradox where you can spend an entire day feeling perpetually rushed, yet arrive at the evening feeling like you haven't accomplished anything at all. The constant stream of fragmented digital input diminishes your subjective sense of time continuity. Your brain is performing so many micro-edits and context switches that the smooth, continuous timeline of your day shatters into isolated, unanchored pieces. This temporal compression has severe sociological fallout. The demand for absolute immediacy short-circuits patience and long-term planning, breeding a culture defined by chronic anxiety and cognitive burnout. Reclaiming control over your perception of time requires consciously resisting this digital acceleration. It means enforcing structured periods of offline focus, starving the system of chaotic input so the brain can establish a steady rhythm again. Our sense of time is an internal simulation, constructed and sustained by our own biology. We protect that timeline by controlling where we aim our attention.